Chemical formulas tell us how many of each element is in each molecule. Some types of chemical formulas can tell us more information, like the shape of the molecule. The simplest representation is with a molecular formula, which only tells us which elements are in the molecule and how many of each type of element is contained. For example, methane contains 1 carbon and 4 hydrogens. The molecular formula for a sulfur molecule could be written as S with a subscript of 8, telling us that it contains 8 sulfurs attached together. A structural formula tells us more about the structure. It tells us which atoms are attached to which other atoms. In the structural formula for methane, we can see that there is a central carbon atom to which the 4 hydrogens are attached. The structural formula for sulfur shows that the 8 sulfurs form a ring. A ball and stick model gives us a 3-dimensional picture of the molecule, while still showing us the attachments between the atoms. We can see from the ball and stick models of methane and sulfur that the molecules are not flat, even though the structural formula is drawn flat. The space-filling model is the most accurate in showing how much space the atoms actually take up. It does not show the connections between atoms as clearly as the ball and stick model, so different models are used for different applications. The numbers associated with our molecular formulas give us important information. A number written in front of a molecular formula indicates an amount of separate items. For example, 2H means that there are 2 separate hydrogen atoms not bonded together. A subscript in a molecular formula indicates that those elements are bonding. For example, H2 indicates that 2 hydrogen atoms are bonding together. If we wrote 2H2, that would mean that we had 2 separate hydrogen molecules, each with 2 hydrogen atoms bonding together. We've looked at molecular formula, structural formula, ball and stick model, and space-filling model. We have one more type of formula to talk about, and that is empirical formula. Empirical formula is more of a mathematical concept. It is a representation of the lowest whole number ratio of the elements in a molecule or compound. If we wanted to write the empirical formula for benzene, C6H6, to get the lowest whole number ratio, we would divide each of the subscripts on both carbon and hydrogen by 6 to get subscripts of 1 for each of them. Generally, for coefficients and subscripts of 1, we leave the 1 off, so we would write the empirical formula of benzene as CH instead of C1H1. Acetic acid, which is the active ingredient in vinegar, has a molecular formula of C2H4O2. We can divide each of its subscripts by 2 to get an empirical formula of CH2O. What is the empirical formula for C4H8O2? Is it A, CHO, B, CH2O, C, C2H4O, or D, C4H8O2? To find an empirical formula, we take each of the subscripts in our molecular formula and divide by the least common multiple. In this case, the least common multiple is 2. We can divide each of the subscripts by 2. So 4 divided by 2 gives us 2 for the carbon, 8 divided by 2 gives us 4 for the hydrogen, and 2 divided by 2 gives us 1 for the oxygen. And typically we leave that subscript 1 off. So we would write our empirical formula as C, C2H4O. If 2 molecules have the same molecular formula but different structural formulas, they are structural isomers. They have the same elements in the same numbers, but they are connected in different ways. For example, acetic acid and methylformate both have the molecular formula C2H4O2. They are bonded differently, though. Acetic acid has the CCO backbone, whereas methylformate has a COC backbone. Some molecules have the same elements in the same number with the same connections, but are still considered different molecules because of the way the atoms are pointing in three-dimensional space. Molecules like these are called spatial isomers. You will learn more about them in organic chemistry.